click this loading, and it may be a different one than we did from class, and as I told you, it doesn't matter. So right click, Object Properties, go to the Parameters tab, and set that regression weight to 1. Okay. Now, since I'm going to do the same operation again for reasoning, rather than closing this tab and everything else, what I can do is just keep this box open, position my cursor over the reasoning, and when it turns red, left click, and all of a sudden the Object Properties box refers to it. I'll type in my 1 and close. And there goes my there are my loaders. Okay, so the last step is that I need to draw the correlation arc between memory and reasoning. Here Amos can be a little temperamental. So what we're going to do is click the double-headed arc. Now when I say temperamental, what I mean is this. Watch what happens when I start at memory and drag down. The arc is perfectly formed. See? Now I'm going to get rid of that. To get rid of a parameter, I'm going to hit the X key and exit out. And what if I start at reasoning and move up? See how it doesn't cooperate? It goes outward like this, which is not good. So sometimes the arc that you draw won't look right depending on where you start. If that happens, like here, you can either start from a different place, or you can hit this resize tool, the shape resize tool again, and just drag the arc out to where you want it to be, like that. And it's another way of shaping the arc the way you want it. Okay, so now we have, I think, this model set up the way we want. All we have to do is play with the analysis properties. Okay, so we're going to go up here. I'll turn off this shape tool. Okay, Vsat analysis properties. Okay, so in the estimation tab, we're going to leave everything as it is. There are no missing data here. We think the data are multivariate normal, so this is going to be a maximum likelihood run, and with no missing data, we won't estimate means and intercepts. We have to go all the way over here to the output tab. Okay, now in the output tab, there are some things we want. We want the standardized estimates. We want the squared multiple correlation, and because we have complete data, we want the modification indices, which I told you if you really want to be strict with statistical significance, you can change it from 4 to 3.84, but truly 4 is fine. We'll get the critical ratios for differences. That's how we get the t-tests. And we'll get the tests for normality and outliers. Okay? So we should be good to go. Close that. So now we're ready to run. I could have seriously made a mistake here, so I don't know if this will work, but let's see. So for model fit, calculate estimates. When we hit that, that should run the model. Now I remember from class that the chi-square for this was around 100, so that'll tell me if I set up the same model or not. So I hit it, it runs, it wants me to save it. So I'm just going to, for now, save it to the desktop. And there you go. And you can sort of see right over here that the chi-square is 100.8, which is exactly what we had in class. So good. So now while we're in this window, we want sort of a quick and dirty look at the results. We can hit the red arrow up here. And that, as you'll recall, fills in the unstandardized estimates, which are toggled by default. If you want to see the standardized estimates, which is what we usually do, that's most akin to what you see in SPSS, we'll click the standardized estimates, and now the numbers are familiar, and basically this figure then is one that you can paste into any Excel or Word or other kind of a program. So in order to do that, one thing you'll notice, I never remember to unselect these 3 reasoning measures down here, and we don't want them copied blue into our manuscripts and stuff. So I'm just going to go over here. I can either do 2 things. I can click the finger and unselect one at a time, or if I have a whole bunch of things I want to unselect all at once, I can go up here and click the fist. Don't ask me why they picked it. Click the fist, and now as you can see, everything's unselect. Okay, so to copy this into a Word document, what I actually have to do is click whole hand, select all, and then edit, copy to clipboard. Okay, and so now what I can do is quickly open a program like Word, Microsoft Office up here. Let's say PowerPoint for a minute. Okay, and I'll make this a blank slide. And now what I can do is paste, and just to control, paste a enhanced meta file, and there it is. Now, as I told you, it's not editable in here, and so it's actually a little bit big. So I'll just double click the picture and change its size to, say, 80% of what I want it to be. Let's see if that's too small. And now I can drag it down, and there you go. And I've got a figure ready basically for publication. It doesn't actually have everything I'd like to show, and there's some things that are non-optimal about it. So, for example, right here, the 69 represents the R² explained in the HVLT total, and that's a really goofy place to be there in the upper right. Or this 47 down here represents the R² explained in letter sets, and that's sort of a goofy place to put it. But on the fly, this is a perfectly good way to get a path diagram for publication. All right, so let's cancel out of that. Alright, so here we are. Now typically, let me hit the fist and unselect everything. So here now we typically want to look at more details of the analysis, and by the time we got here to Amos 5, I think the output box was much more useful than it had been in Amos 4. So remember that to look at the output, we have to go over here to this ledger box, click it, and there goes the output. I'll maximize it. Alright, and what you see here on the left then is different aspects of the output. So it's organized very much like SPSS. And for the most part, you don't need to spend a lot of time looking at pieces of this. It is usually useful to look at notes for group, because if there are any estimation problems or if the final solution is inadmissible, this window will tell you. The variable summary is again, not anything particularly important, but it's a way for you to look at this and make sure that you have the right number of variables, the right number of factors, and so forth. Same thing with the parameter summary. We reviewed it in class, but honestly, it's not particularly important information. The biggest thing is this final total column, where what we can see is that we started with 21 degrees of freedom in the correlation matrix. We estimated 13 parameters, so we have 8 left over, which explains why we have 8 degrees of freedom. Because we have no missing data, we can look at the assessment of normality, and as we talked about in class, each of the individual variables look like they're univariate normal. The CR represents the t-test or critical ratio. The Mardia's coefficient of multivariate kurtosis is significant, but it's under 2, which most people, or under 3, which is the kind of cutoff that most people would use before deciding they have a problem. There is this multivariate outlier thing using Mahalanobis. And so you can go through here. These are just the worst cases, and you can go through here, especially in a smaller sample size, and consider for elimination some of these extreme outliers. Like case 1201 is just so far away from every other outlier that that's one I would give some serious look at to decide whether that case should be a model. Alright, so now we have notes for model, and that's just an overall summary of the degrees of freedom and chi-square. We'll see that again when we look at goodness of fit. What we really care about are the estimates. So the estimates are the same as what we looked at in class, but they're prettier now. Okay. So what you see here under the regression weights are the unstandardized estimates. We look at that table to see whether any of the loadings are non-significant. As you can see, they all have 3 asterisks under P, which means they're less than 0.001. So looking at the standardized regression matrix box, this one, we see the sort of familiar metric loadings, and those are loadings that we will report. So we can report the significance from up here and value of the loadings down here. And you'll explain why you don't have significance for the first and fourth loading, because those are the loadings you chose to use to scale the solution. Now what we have is the covariance matrix. And again, this is a test of the significance of the relationship between memory and reasoning, and that's significantly different from 0. And then here we have the bivariate correlation. And then finally at the bottom, what we have are the variances of the memory and reasoning factor, which for the current purposes we don't need to do anything with. In the future, when we do regressions, that's the variance we're going to be trying to explain. So it's a lot like what we did in MLM. Those variances for memory and reasoning represent the kind of the variance that we want to explain and reduce. And all these variances